Hello.
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 Yes, ma'am.
Yeah, can you hear me?
Yeah, ma'am. Yeah.
Okay.
Okay. Yeah, everyone is properly getting our voice.
Yes, ma'am.
Okay. So very good evening to all of you. Myself, Jaya Mukherjee, welcome you all on behalf of Chavas Engineering College in today's one-day webinar. Today's our guest is Dr. Kriti Mukherjee, Research Fellow in Remote Sensing, Center for Environmental and Agriculture Informatics, School of Water, Energy and Environment from Cranfield University, Bedford. And I also welcome our principal sir, Dr. Ranjit Rai. But before starting our webinar, I would like to introduce our guest speaker, Dr. Kriti Mukherjee Madam. She did her bachelor's in electrical engineering from Jadavpur University, Kolkata, and master's and PhD in geomatics engineering from Indian Institute of Technology, Roorkee. She worked as a scientist in National Technical Research Organization, an intelligence organization for 8 years. Her role was to analyze and extract intelligence information from satellite images. After that, she moved to Germany for further research. She has worked in TU Dresden, Germany for 2 years and in University of Northern British Columbia, Canada for 3 years. During this period, she has gained extensive research experience on how the high mountain glaciers are reacting to the climate. Based on her research, she has published several papers in multiple peer-reviewed journals of international repute as a leading author and co-author. Currently, she is working at Cranfield University in the United Kingdom. She is working on the project Theory of Change Observatory on Disaster Resilience. In this project, she wants to develop methods and techniques to address natural disasters like droughts and floods. She has expertise on using various kinds of satellite images, software programming languages, and various open source tools and applications to extract and visualize meaningful information from geospatial data. Today she will talk about how remote sensing help us to monitor the extreme events, build more resilience, and prepare towards a more sustainable future. And her message to the future generation is, if you want to feel young forever, never stop learning and never let anyone else to decide what you will learn. And one more information additionally I am sharing with you. If you have any queries regarding your higher studies, you want to study in foreign countries, you want to go for research, at the end of the session, ma'am is with you. You can ask question. She is this. She is currently in foreign university only. If you want to pursue your further education, you can ask questions, and whatever questions in your mind throughout the session you are having, please ask to madam at the end of the session. And madam, welcome to you all. And I will hand over this session to you, madam.
Okay, thanks, Jaya, very much for the introduction. And hello, everyone, students and all the professors who are here. I cannot see anyone. So anyway, I just want to let the students know that there is a chat option you can see at the bottom of your screen. So you can just go there and type whatever question comes in your mind. And at the end of my talk, maybe I'll or your madam will see the questions and ask me. Okay. So don't be scared and you can ask anything you want. Okay. So I will just now start sharing my screen. So just let me know whether you are able to see it.
Yeah, ma'am, it is visible.
Okay. Okay. Thank you. So today I'll talk about climate change, its consequences, and how remote sensing helps to monitor such events. Here you can see the different kinds of extreme events that is observed more frequently in the recent decades with the global climate change. We are seeing an increase in glacier melt, an increase in forest fires, an increase in both intensity and frequency of flood events, and more frequent droughts. I'll discuss about some of these aspects in more detail today. I will not go into much technical details, but I'll give you an overall idea of why climate change is happening and why we should be serious about the way we consume energy. I hope you will find it interesting. So let's get started. So do you remember what happened on 7th February 2021 in Uttarakhand, India? This slide shows you that. The paper was published in Science in June 2021. There was a catastrophic mass flow that descended the Ronti Ghar from 3,700 meters and went through Rishiganga and Dhauliganga valleys in Chamoli, Uttarakhand, India, causing widespread devastation and severely damaging 2 hydropower projects. The blue line shows the path along which the rock flow traveled. So this is the line. More than 200 people were killed or were missing. Here you can see the red box, which is the location where it originated. So it originated from this location. Now see the images B, C, and D. B is the image of January 1, 2021. That is 1 month before the incident had happened. You can still see the crack on this image here. Now see the image C. C is captured on February 5, 2021, 2 days before the incident. The area is still visible where the crack is, and you can see this, now this area is fully covered by snow. Next, see the image captured on 10th February 2021, 3 days after the disaster. You can clearly see that chunk of the rock is now missing from here. So, and a hole is created there. Now see the top left image again. This chunk of rock was at a high elevation. When it got detached from the source, it fell downslope, carried a lot of debris along the path, flowed south along the valley and toward the right, where it damaged 2 hydropower plants. First, Rishiganga hydropower plant having a generating capacity of 13 megawatt, and second, Tapovan hydropower plant with a plant capacity of 520 megawatt, which was still under construction. On the right, you can see the newspaper clipping and the damage from ground level. The possible causes were identified as long-term changes in cryospheric conditions and thermal disturbances in bedrock conditions due to climate change and rock instability due to glacier retreat. Key questions were raised about adequate monitoring and sustainable development in the Himalaya, as well as other remote high mountain environments. Between 1894 and 2021, the Uttarakhand Himalaya has witnessed at least 16 major disasters, from flash floods, landslides, and earthquakes. Hydropower projects in Uttarakhand and elsewhere in the region have been opposed over their environmental effects, public safety, and issues associated with justice and rehabilitation. Human activities that intersect with the mountain cryosphere can increase risk. However, they are common in Himalayan valleys where hydropower development is proliferating because of growing energy demands, the need for economic development, and efforts to transition into a low carbon society. A similar incident happened in British Columbia, Canada on 28th November 2020, that is just 2 months before the Chamoli incident. A mass of rock descended 1,000 meters from a steep valley wall. You can see on the left the satellite image as taken on 15th August 2020, 3 months before the incident. On the right, you can see the mass of rock that traveled across the toe of the glacier before entering into the lake, and it produced a tsunami with waves higher than 100 meters. The outburst flood destroyed forest and salmon spawning and rearing habitat. I was also involved in this work to understand what happened. We used a physically based model to provide a real-time simulation of the event. The trigger for the landslide is still unknown, but factors that led to the failure include fractured bedrock and deeper tracing of the base of the slope due to glacier retreat in a warming climate, and an increased amount of precipitation before the event. The paper is now under review. Now you can see the graphs of global temperature changes in this slide. It is clear that the temperature is increasing in an unprecedented manner in the recent decades, as measurements from different sources strongly agree with each other. Earth's temperature has risen by 0.08 degrees centigrade per decade since 1880, and the rate of warming over the past 40 years is more than double of that, that is 0.18 degree per decade since 1981. 2020 was the second warmest year on record based on NOAA's temperature data, and land areas were record warm. 2020, however, was a La Nina year, that is the year when Earth is expected to be colder than normal. However, despite a late year La Nina event that cooled a wide swath of the tropical Pacific Ocean, 2020 came just 0.02 degrees centigrade shy of tying 2016 for warmest year on record. From 1900 to 1980, a new temperature record was set on average every 13.5 years. from 1981 to 2019, a new record was set every 3 years. These facts are very concerning as none of these can be considered natural, and we, the human beings, are responsible for all these changes. One of the most direct effects of climate change is evident from the change in global glaciers. We are seeing an accelerated increase in melt of glaciers in almost every part of the world. Here you can see how the global glaciers are melting in the recent decades. This paper was published in Nature in October 2020. Red denotes a glacier melt or loss, and blue denotes a gain. Glaciers are denoted by violet color. You can observe that everywhere in the world, we are now observing glacier loss. That means more and more water is lost from the glaciers, and they are added to the sea level. Loss is more pronounced in several regions like Greenland, Alaska, Western Canada, Iceland, and Europe. The glaciers in South Asia West, that is the glaciers from Karakoram and Pamir, so here, these were in balance until the first decade of this century. However, in our most recent study published in Nature Communications, it was revealed that these glaciers have also now started losing mass in the most recent decade. You can see the results of this study on this slide. See the two bottom left circles here. They represent glaciers from the Karakoram and Pamir regions. See the contrast with other circles. Based on these and many other studies published elsewhere, it is now an well-established fact that the existence of the glaciers are in threat. There is also an increase in sea level because of the glacial melt and expansion of water, warming climate that endangers the ocean ecosystem and coastal population. Here on the right, you can see a glacier and a lake at the terminus of the glacier. On the left, you can see a similar phenomenon drawn by hand. The terminus of the glaciers are at a much lower elevation than the accumulation part or the top of the glacier, and therefore melts faster and sooner during warming. Sometimes the bed of the glacier at the terminus may hold the meltwater and thus form a lake over time, as shown on this slide. However, these are just natural moraine-damped lake. If at some point of time, the glacier melts a lot more than the normal rate, or there is an increased amount of precipitation, or an avalanche from the top of the glacier, from the mountains or from the surrounding regions that flows into the lake will overflow and all the water along with the debris will flow downstream where it destroys the human settlements and the infrastructure. In a similar incident in 2013, more than 4,000 people died at Kedarnath, Uttarakhand, India, when a moraine-damped lake breached after heavy rainfall and snow melt. Such incidents are known as glacial lake outburst flood. There are a large number of glacial lakes in the eastern Himalayan region, and therefore this region is quite vulnerable to such outburst floods. In addition, it was also shown in a study that glacial lakes exacerbate glacier mass loss, which means that glaciers having lakes at their terminus are more prone to melt than the glaciers without a terminal lake. Now I come to the point where I told that we human beings are responsible for the climate change. Here you can see the graph of global population over the last 12,000 years. We see that the population was 600 millions in 1700 and increased to 1.65 billions in 1900. This means in 200 years from 1700 to 1900, the population increased by approximately 1 billion. However, the rate increased considerably after that, and in the 60 years within 1900 and 1960, population increased by 1.35 billions. Finally, in the last 60 years, the population increased by 4.7 billions. And the reason behind such accelerated increase is industrial revolution, which started from around 1760 and changed our lifestyle altogether. We transformed from an agrarian and handicraft-based economy to one dominated by machine-based industries. The Industrial Revolution started in Britain, Europe, and America, and other countries gradually followed the suit. While machines made our lives a lot more easier, but the sources of energy to run the machines and power plants are causing a lot of harm to the environment, as they increase the amount of greenhouse gas in the atmosphere, which is responsible for the global warming. Now you may ask the question, what is greenhouse effect exactly? So here is the explanation. When light energy from the sun is incident on the earth, part of it is reflected back to the space through the atmosphere, part is transmitted into the ground, and rest is absorbed by the atmosphere, different constituents of the atmosphere, such as water vapor, carbon dioxide, ozone, methane, or nitrous oxide. In addition, Earth also emits its radiation in the 3 to 50 micrometer zone of the electromagnetic spectrum, and part of that energy is also emitted to the space, and part is absorbed by the atmosphere. Therefore, these atmospheric constituents trapping the electromagnetic energy are known as greenhouse gases and act as a blanket to make our Earth livable. In absence of these greenhouse gases, our Earth would have been much colder than today. However, a proper balance needs to be maintained so that life can sustain on the Earth. If the percentage of greenhouse gases exceed than the normal amount, the Earth keeps trapping more heat than normal, and the temperature keeps on increasing. This is what is happening from the last few decades, especially after the period of Industrial Revolution, as more fuels based on carbon are being burnt, and the result is an increased percentage of CO2 in the atmosphere. Here you can see another environmental degradation, that is deforestation, which is now widely happening in Southern America and Africa, and also to some extent in India, among other nations. The trees and forests are the natural sink of carbon dioxide, one of the greenhouse gases in our atmosphere. We are on one hand generating more carbon dioxide by burning fossil fuels and increasing our population and thereby exhaling much more CO2 than 100 years back. And on the other hand, we are cutting down the trees, which could replenish the amount of CO2 in the atmosphere. Overall, we are disturbing the balance in the atmosphere and endangering our own existence. Another environmental damage we are causing is by rapid urban development. As there are more and more people in the earth, they need more and more place to live, more food, jobs, etc. Most of the industries and therefore the jobs are now in the cities, and to accommodate the population pressure from remote villages to the cities, there is a rapid urban development. While people are perhaps getting jobs and a place to live, but there is a decline in the overall urban environment, including its air and soil quality. Soil quality also declines when the same type of crop is repeatedly harvested instead of a cycle of few different crop types. This is happening because of the food habit we have developed, especially the people from the developed nations. There is a high demand of meat from cows, that is beef, in the developed nations. To produce that amount of beef in demand, they need to produce that much of animal feed. For example, 60% of Germany's agricultural land is used to produce only animal feed, and market forces determine which crops will be cultivated. So the crops which feed the animals, such as cows, are produced more. Same crops for many years make the soil infertile. Then we use fertilizers which make the soil quality even poorer. On the other hand, cows are the producer of considerable amount of methane, which is another greenhouse gas. Thus, by changing our eating habit, by switching to other sources of meats and vegetables, we can help maintaining the soil quality and also reduce the amount of greenhouse gas emitted to the atmosphere. Any change in land cover and land use is also associated with a change in evapotranspiration, which is the amount of water lost through evaporation from soil surface, water surface, and trees. All these changes ultimately disturb the Earth's energy balance and act as a positive feedback to increase the temperature further. Now I will talk about some of the risks as a result of all these changes I just mentioned. The coastal areas are most vulnerable to the sea level rise, and it destroys the livelihoods of millions of people. You may all know about Sundarbans, the delta in the coast of India and Bangladesh. There is the largest mangrove forest on earth. The recent disappearance of some of the islands due to sea level rise and coastal erosion caused the local people to emigrate and become environmental refugees who will cause population pressure in neighboring regions and urban centers. The biodiversity decline due to sea level rise also endangers the existence of the Bengal tigers. In addition, an increase in soil salinity due to seawater contamination hinders the plant growth, agriculture crop irrigation, and deteriorates the quality of drinking water. Here you can see an elevation image of Sundarbans area overlaid on a satellite image. Color green indicates lowest elevations and red indicates highest elevations. The authors of this paper studied how the mangrove area will be lost due to the projected future sea level rise. Mangroves provide buffer from floods and erosion. However, due to the sea level rise, considerable amount of mangrove population is being lost. On the right, you can see the map showing the scenario with a sea level rise of 148 centimeter in red and different mangrove species in other colors. They state that some of the mangrove species will lose more than 25% of their habitat with this amount of sea level rise. The accuracy of such results depend on many aspects, such as which data has been used for classifying and mapping the mangrove species, what resolution has been used for the image and the digital elevation model, etc. However, the fact that sea level rise is threatening the coastal lives remains unchanged. Another risk of increased temperature is an increase in precipitation or rainfall, both in intensity and frequency, which increases the flood risks. The water holding capacity of air increases by about 7% for each degree rise in temperature. This results in increased amount of precipitation and subsequent flooding. In the past decade, reported annual losses from floods have reached tens of billions of US dollars and thousands of people were killed each year. A study published in Nature Climate Change demonstrated that there will be large increase in flood frequency in Southeast Asia, peninsular India, Eastern Africa, and the northern half of the Andes as shown here. The figure shows the aspects of most dangerous climate change outcomes for the near end of this century. Dark blue color represent the smallest return period, which means the chance of flooding in every 2 to 5 years. The colors to the right indicate less risk. Flooding can be of different types, such as coastal flooding, river flooding, flooding from groundwater, and surface water flooding. The sources are also different for each type of flooding, and while modeling any flood incident, each of the different types of flooding need to be treated separately. In England and also in India, surface water flooding is now a great concern. Approximately 3 million properties in England are at risk from surface water flooding. This type of flooding, also known as flash flooding, is often caused by a convective weather pattern and is usually accompanied by short-lived, intense, localized rainfall. Flash floods are different from coastal or fluvial flooding mainly because of its lifespan, which is typically in hours compared to other types of flooding, which last for days. However, we may get a months of rainfall within just few hours and it overwhelms the local drainage. Water stays on the ground until it finds a way through the drainage. The risk of surface water flooding is increasing in the recent decades with an ever-increasing population, rapid urban growth, and global warming leading to increased uncertain precipitation, making more people and properties vulnerable to the risks. Here on the top left, you can see the picture of Storm Desmond that happened in the UK in December 2015, which was an extratropical cyclone and directed a plume of moist air known as atmospheric river, which brought record amounts of rainfall to upland areas of UK and subsequent major floods. Record-breaking amounts of rain fell in Cumbria, the worst hit country. This is Cumbria, shown in red, causing widespread flooding. A total of 446 properties were affected as a result of 300 millimeters of rainfall falling over a 24-hour period, whereas the monthly rainfall in December is usually within 100 millimeter to 150 millimeter. In the UK, there are many agencies, in addition to the government, who are responsible to manage the risks of flooding. For example, Environmental Agency is the main agency who provide flood maps for the whole nation. However, they do not model the risks from surface water flooding, and the local authorities are responsible to model such risks. But local authorities are not often enough technically competent to provide such information, as modeling surface water flood risks is quite complicated. We need to use advanced flood models, high-resolution elevation data, and do various kinds of uncertainty assessments to provide the most accurate flood risks. Here on the bottom left, you can see a DEM of 1 meter resolution, representing the range of elevations for the area. The lowest elevations are in red, and the highest elevations are in blue and violet. On the right are the flood extent maps simulated using this DEM. The top left map was supplied by the Environment Agency. However, they have missed some of the area as shown by the red box. In addition, this flood map was produced considering that the flood was caused by the rivers only and floodwater did not cross the river basin shown by the black solid line here. However, this was not true as the simulated flood extent, this figure C, considering both surface water flooding and fluvial flooding, that is flooding from the river, shows that the flood extent was much beyond this black line. And you can see all these blue colors are actually representing the flood. So therefore, the damage and risks are not estimated accurately, and very often people are not aware that their properties are at risk from flooding. Currently, one of my research focus is on a better management of surface water flooding in the UK. Another risk of climate change is the occurrence of more frequent droughts. This is another aspect I'm focusing on right now. This project is on developing a set of tools and models to better predict, assess, and respond to disasters in sub-Saharan Africa, more specifically, droughts in terms of disasters. Drought is a weather-related complex natural disaster that can occur in any climatic regime around the world and causes considerable damage to agriculture and economy of a country. Drought happens when there is a lack of precipitation for a prolonged period of time, leading to depletion of soil moisture, surface water, or groundwater, and thus lead to an overall drier than normal conditions, leading to reduced plant growth. Drought occurs when more water is used than replenished. It is a balance between supply and demand with both natural and human factors to play. The climatic circulation patterns of our Earth are constantly changing. In simple words, if there is a low pressure system, the warm and moist air rises above, then cool and form rain clouds. However, a high pressure system traps the air beneath it and banishes the cloud. Droughts form when change in climatic circulation patterns cause high pressure system to last for months or even years, ultimately leading to a much more demand of water than available supply. If the demand cannot be met for a long time, crops eventually begin to dry. Short-term drought cause stress on both the environment and people. Long-term drought can lead to war, famine, disease, or even mass migration. The best we can do is prepare for it before everything blows away. Droughts are one of the most costly natural disasters on a year-to-year basis. Their impacts are significant, affecting many economic sectors and people at any one time. Effects of droughts affected regions are usually more widespread than in any other natural disaster like flood, landslide, storm tracks, etc. Because of its slow onset, it is possible to monitor drought much better than the other disasters, as we have more data to analyze and understand the onset as well as the termination of drought. According to World Risk Report 2016, 35% of the global droughts occur in sub-Saharan African region. In sub-Saharan Africa, droughts account for less than 20% of natural disasters, but account for over 80% of the affected population. 8% of the disasters are caused by drought in the sub-Saharan Africa, whereas for the whole world, this number is 4%. There were at least 6 to 8 droughts during the period 1990 to 2014 in sub-Saharan Africa. You can see in these pictures how drought affects the landscape. The trees dry out or die, more and more land becomes barren and soils appear dry. The water levels decrease in the ponds, lakes, and reservoirs, and all these changes can be monitored through remote sensing from space. We can use various drought indicators such as precipitation, soil moisture, vegetation, and indices based on these, along with the information about local topography, land cover, classes, and soil types to understand the regions most vulnerable to drought. There are 4 different kinds of drought: meteorological drought, that is caused by lower than normal precipitation for a prolonged period of time; then agricultural drought, which is caused when plant available water falls below the required limit, usually during a critical crop growth stage; hydrologic drought, caused when a combination of factors such as stream flow, soil moisture, or groundwater is not available; and socioeconomic drought, which is caused when a loss occurs in expected return, usually measured by social and economic indicators. One of the most prominent drought indicators is precipitation that can be measured using rain gauge installed at the different weather stations across any country. However, weather stations are not very common in remote areas or high mountains. In absence of weather stations, precipitation can also be measured from the satellite data collected in multiple wavelength regions such as visible, near infrared, or microwave. In addition, numerical weather prediction models are also used to generate global gridded precipitation data, which are also quite accurate as they use observations from meteorological stations across the world with the model data to provide a best estimate. Standardized precipitation index is the most commonly used precipitation-based drought index. The parameter can be effectively used to calculate wet periods as well as dry periods. This is based on the probability of precipitation for any time scale. The probability of observed precipitation is then transformed into an index. Ideally, we need 50 to 60 years of data, but at least 20 to 30 years of data is recommended, and that is the minimum time period to understand the average climate of any region. Suppose we have a monthly precipitation record available for 40 years, as you see on these graphs. I just wanted to show you how, just by looking at the monthly precipitation records from two different places, one from Tanzania and the other from the UK, you can understand why the location in Tanzania is more prone to drought and the location in the UK is more prone to flood. You can see that for a few months in each year, there is almost no precipitation in Dodoma, Tanzania, whereas Cockermouth in UK receives precipitation all through the year. We can also see that there was a huge amount of precipitation in December 2015 in Cockermouth, and most of these precipitation occurred in a single day in December 2015, leading to a flood event that I just described before. From the monthly precipitation, we can then calculate a set of I months moving averages of this record, where I is 3, 6, 12, 24, or 48 months. The different time scales help to deal with different types of droughts, as I mentioned before. For example, the shorter periods like 1 or 3 months SPI resemble the meteorological drought. 1 to 6 months SPI represent agricultural drought, and something like 6 months to 24 months SPI or more represent hydrological drought. Each of these data sets are then fitted to gamma distribution as shown here to define the relationship of probability to precipitation. Once this relationship is established from the historic records, the probability of any observed precipitation data point is calculated. Then we find the inverse normal of this probability value to calculate the precipitation deviation for a normally distributed probability density with mean 0 and standard deviation of unity. Finally, we can plot the SPI values corresponding to each month for the different series of moving averages. You can see how the values change as the series changes. The values within 0 and 1 correspond to normal conditions. More positive values indicate a more wet condition, and more negative values indicate more dry conditions. Thus, following this method for each location, we can find all the spatial and temporal extremely dry or extremely wet points from a large data set and monitor the drought or flood events. This figure shows standardized precipitation index calculated using satellite observations of precipitation. The product was able to capture the 2010 Russian and Amazon drought. Finally, coming to my expertise and what all I do for getting my work done. I have a specialization in geomatics engineering that is more popularly known as remote sensing. Remote sensing suggests the information captured from satellites, aircraft, or drones. Satellites are flown at the highest altitude and drones are flown at the lowest altitude. Accordingly, the images captured from satellites are at a coarser resolution, and images captured by drones are at a finer resolution. By resolution, I mean the spatial resolution, which is equivalent ground area represented by each pixel in the image. Whatever image we capture using remote sensing, we need to first pre-process them to make them ready for analysis. Pre-processing means radiometric, atmospheric, and geometric correction of the images. After all these corrections, we generate the GeoTIFF images, where each pixel of the image is represented by its appropriate location on actual ground surface. With the launch of new satellites quite frequently in the recent decades, the amount of images have been increasing exponentially. Therefore, the challenge that lies ahead of us is to apply efficient methods so that we can extract the required information from a huge amount of data automatically. Very often, we need to use a huge number of images to detect the changes over time, apply various classification and segmentation methods, etc. I therefore use various machine learning and deep learning methods for doing such analysis. Another important output from the remote sensing images is the digital elevation models. For example, if we want to calculate the elevation changes of the glaciers all over the world for a specific period, we need to generate hundreds to thousands of elevation models. We again need to automate the process as it is nearly impossible to do this manually. I monitor the events such as glacier changes, droughts, and floods using remote sensing data. To do this, I use data of various temporal resolution. For example, for glacier change, we may need data at a decadal time gap, whereas we may need hourly or monthly climate data to understand the influence of climate on such phenomena. I use different physically based models to simulate the glacier changes or the flood events. Here you can see the evolution of Place Glacier in British Columbia, Canada, simulated over the last 40 years. That was the outcome of my last project in Canada. Quality and accuracy of such simulations depend on the quality of the input data, such as the DEMs or climate data. Finally, I collaborate with other universities and industries. For example, I have collaboration with universities in the UK, Canada, US, Brazil, and India. Currently, I am working with some of the industrial partners in the UK, such as Floodre, which is a flood reinsurance company, Environment Agency, which is a government organization, and Bedford Borough Council, which is a local authority for dealing with the flood events in the UK. So that's all for today. And I thank all of you for your patience, and let me know if you have any question. I'll be happy to answer.
Ma'am, what is electromagnetic energy?
Electromagnetic energy actually is sunlight. Okay. Sunlight is actually electromagnetic energy. Now we can see the sunlight only in the visible region with our eyes, but total sunlight, if you think about it, that is the electromagnetic energy. It ranges from UV ray to microwave region. It is a large region. We cannot see anything beyond visible region.
Ma'am, as you have said that due to high industrial uses and larger population, climates have changed drastically during last decades. But during this corona period, about 2 to 3 years, mostly industries have been shut down. So then, what are the changes that have come due to this time on our
No,
climate?
nothing much. No, industries are not shut down at all. Wow. Maybe for a few days only during Indian first lockdown, but you cannot close the industry, otherwise economy will stop. We have to also run the economy. And the most important point is that if a carbon is added to the climate at some point of time, it takes hundreds of years to go away. So means whatever has already been added, it will take hundreds of years to go. So in our lifetime it will not go. 1 or 2 years is nothing. Okay, so we need to be very serious about this, and we need to change our habits and start thinking about, if you are from electrical engineering background and you are into energy, means you want to think about how to come up with alternate sources of energy. That should be your concern. Actually, means mine is remote sensing, so I try to monitor the changes. Whether we are going in a bad direction or in a good direction, I can monitor those. But if you are in energy sector, you need to think about coming up with different sources of energy than fossil fuel based energy. Okay. Okay, there is another question. What is the reason behind the decrease in level of groundwater? Yes, because that is also because of the urban development, and there is a lot of construction activity going on. We need water for our drinking purpose, for agriculture, for construction, for everything. We need the water, and we extract that from the ground, under the ground. So in that way, we are decreasing the level of groundwater. That is a good question.
Ma'am,
Yes.
as you have said that water level is rising, due to which certain islands have disappeared. Some islands have disappeared.
Yeah.
Then why doesn't the extra water which is rising above the sea level is going underground?
No, extra water, it is not so simple and easy, because the water, what is in the ground was already there in the ground from so many years, and the fresh water, it will not mix with the ground so fast. It takes a lot of time. Everything actually takes a lot of time, and the population is growing so rapidly. Urban development is going so rapidly that it is not able to maintain with this natural cycle. So that is where we are disturbing the balance of the environment. What is this black box of art? I could not understand. Can you please elaborate what you want to say? I could not get your point. Okay, the next question is, how can we go to for okay. Okay, so
I have read an article about the black box of Earth,
okay,
but I couldn't understand the appropriate manner. What is the need of this black box?
I don't know what you mean by black box of art. This is a new term I am listening today. So you first you explain what is that, then I will be able to say something.
Okay, ma'am. Then it is like in aeroplane there is a black box which tells us about the condition of the plane, the height of the plane, at the means it stored a lot of data when accident happen, like जो CDS विपिन रावत जी का निधन हो गया जिसमें
So why is it a
उसको
black box?
yes ma'am
Black box means we don't know anything about it. Black box means, if you theoretically, what I understand, black box means when we don't know whatever is happening within the system, we call it a black box. But if you are saying that there is a lot of data, then that we can use to reveal what had actually happened, then how can we call it a black box? First of all, I need that explanation.
no questions ma'am.
Okay. Okay, no, first you have to understand what you are asking and what you are thinking, because if you call something a black box, then we don't know anything about it. That's why we call it a black box, right? That's what I understand. So think more about it. Maybe you have a question, but you cannot express it properly. Maybe you can come up with the question later with more explanation, right?
Ma'am,
Okay.
black box is it is a box which carry all the information, and the person inside that plane, they are talking, all things are recorded in that box, and every information recorded in that box, and it is very strong, means if anything happened, like if plane crashes, then that box not get destroyed or not damaged.
No, it can get destroyed, but in this case they may be able to recover something from that box. Anyway, maybe there is no connection with your my presentation with your question, so I am not going into those details right now. Okay, so please point out some ways for groundwater recharge in metropolitan urban areas. This is not my area of specialization. Which type of softwares that you are using for simulation of the data that we collect? Software depends on your application. For my application, I use remote sensing software, and for every subject, for every specialization, the softwares are different. So no one software suits all the jobs. You have many different, and I mostly use my own scripts to solve the problems. Nowadays I don't use the softwares that much. Okay, so I will answer this question because the ma'am also wanted me to tell about this, how we can go to foreign universities. Okay, so if you are a graduate student, then for post graduation, there are some options, like if you can get an admission in any of the IITs, then there is a kind of a sandwich program which is known as DAD, which is within Germany and India. So the students get a few months of research opportunity in one of the German universities. And for their dissertation, there is a 1 year, or I don't know how many months is now given for doing the dissertation in masters. So for masters, there is that kind of option. And otherwise, masters completely without any scholarship, it is difficult. If you have a lot of money, you can think about it. Otherwise, it is really hard, because it is extremely expensive to stay in foreign countries. And then and in masters, the scholarship is also quite less, and if you can maybe just somehow you can survive there, I would say. And then in PhD, you can again try, but means you need to publish papers in reputed journals based on your publication and based on your academic experience. You may get a chance to do PhD in any of the foreign universities. And similarly, after PhD, if you want to go there for postdoc, again, you need to publish. Means publication is very important, but publication in reputed journals, not just anywhere or not just anything. So your publications should have something potential, that's something you have, some research you have brought some new knowledge, you have contributed in some new way to the scientific community. That is very important. So if you want to go for higher studies, those are the ways. And there are some other ways also, like entrepreneurship. There are so many people coming to these countries for that. And also in Canada, there is a permanent residence scheme. If you have some work experience in India, have some degrees from India, then you may just try and see what is your score, whether you can apply for permanent residence in Canada. And then after going there, you can try and find jobs. That is also an option. So depends on different countries. Every country have their own rules. So you have to keep tracking, and you have to communicate with other people or your seniors who have already been there. And those are different ways. Okay, is there any more question?
Ma'am, during higher studies, when
Yes.
we invent or any innovative idea, what is the platform to show our idea?
Platform, there is no any such platform. You can apply for conferences, and then you can present your work there, and you need to communicate with the professors who are working abroad if you have any idea, or if you're interested to work with them. And it is not that what you are interested in, you have to also see what the professors are doing, what the research they are doing, and what is their specialization. Accordingly, if that matches with your interest, then only you should approach. Otherwise, you will not never get any answer. So yeah, I would say conferences is a good option to showcase your talent. Okay, so this question, what are the things we undergraduate need to take care now, which will help studies abroad in it? Score or marks? No, not score or marks. It is your publication. Score or marks doesn't prove anything. You don't need to bother much. Only you should work hard. You should study. You should try to understand the things. You should not bother how much marks you are getting, because they don't prove anything at all, I think. And mainly you should focus on, if you want to do further research, then you should focus on your research. You should be passionate about your research, and you should continue in a proper direction with proper focus, and communicate with the professors who are working in your area of interest. So in that way only, I think. There is a okay, what is the difference between Indian universities and abroad universities? Yes, it is a very good question. There are a lot of differences, and I would say in Indian universities we are still thinking like we can, like the last question, whether we should focus on scores. No, not at all. And you should not at all just go through the books, what is written in the books, and remember and write those in exam. You prove nothing with that. You can do nothing with that. You have to actually understand what is going on in this world at this point of time, and what are your roles, how can you address those problems, and you can make the world a better way. So abroad universities are thinking in that direction. They don't think like you have to just read books and you have to get marks. They don't, not at all in that way. That is a very, very big difference between what we are taught in our universities. I was also taught in the same way. So don't worry, you can change your thinking at any point of time. Okay. Okay, I think it is 1 hour already. So Dr. Roy and
Yeah,
John,
ma'am.
yeah,
Yeah.
the rest of the questions you can just send me. I will try to answer those, but I have other already other engagements. So
Okay, ma'am.
yeah.
So, ma'am, thank you very much for accepting our invitation
No,
and
my pleasure.
encouraging
Thank you
our
very
students. Ma'am, very interesting, ma'am, very informative this session is. And the students also participated very well, and they have many queries. You have answered them very well.
Thank you so much. Yeah,
Thank you.
and
Yeah, the
yeah.
session was very nice session, ma'am.
Thank you so much.
And thank you, ma'am. Once again, thank you for accepting this kind of talk. We will like to have in future also with you.
Yeah, it's okay. Thank you. It was my pleasure.
Okay, and
and
thank you to all.
Ma'am.
Yeah, thank you. Thanks to all of you and all the students.
Yeah, and I also like to thank our principal sir for inspiring and working towards such types and encouraging these types of programs, because it will help our students to support them for future.
Sure.
Okay. Thank you to all the students also and all of you present.
Thank you, ma'am.
Thank you. Bye-bye.
Okay, bye-bye. Okay.
Bye,
We are
ma'am.
concluding this session. Thank you to all.
Thank you, ma'am.
Thank you.